So this will be a short lesson on parallel and perpendicular lines. So first we should talk about what each of those are. We kind of have three options for how two lines can interact with each other. First option is they intersect but don't have any kind of special relationship. Okay, so then the second one is they intersect in a specific way at a 90-degree angle or right angle. Okay, and so that means they intersect only once right there, and this is called a set of perpendicular lines. Okay, so they have a special kind of slope. If this line right here has negative slope and this line right here has positive slope, already we kind of are seeing that they have opposite slopes, and they truly do have opposite slopes. So if our first slope is m1, then the second slope would be the negative reciprocal. Okay, so they're literally opposites. If we have a slope of, let's say our first slope is 2, then our perpendicular slope would be, so sometimes they call it like that little kind of perpendicular line there, would be negative 1/2, right? We literally flip it, change the sign. So if we started off with, instead of 2, if we started off with negative 4/3, let's say, our perpendicular slope would be positive, and flip it to be 3/4. All right, so then our third type of interaction of lines is where they don't intersect at all. They go along next to each other, not at a certain distance necessarily, but just next to each other, never intersecting. This is called parallel. They also have a special kind of slope. We can kind of even guess what it would be. They never change the distance between them, right? So that means their slopes are the same. It literally doesn't change. So either of those two slopes that I was talking about before with the perpendicular, well, if our slope is negative 4/3, our parallel slope is also negative 4/3. If our slope is 2, then the parallel slope is 2. It literally doesn't change one bit. So next is if we're given kind of 2 points, and we want to know, 2 sets of 2 points, we want to know if those represent parallel, perpendicular, or neither type of line. So if line 1 has points 2, -3, and 4, 1, and line 2 has points 5, -6, and -3, -2. Well, the only way we know to tell if it's perpendicular or parallel or neither is from the slopes. So we need to calculate the slope of both of these sets of points. So let's calculate slope 1 for line 1. That would be y2 minus y1 over x2 minus x1. It doesn't matter which point we do first. I'm going to choose this one first, the 4, 1. So 1 and 4 minus minus -3 and 2. So this is a point and this is a point, and subtract in the middle. So simplify across. A minus minus is really a plus, right? So 1 plus 3 is 4. 4 minus 2 is 2. So 4 divided by 2 is 2. So this is our first slope. Now we need to calculate our second slope. Again, same idea. It doesn't matter which one you choose. I'm not going to choose the fully negative one just because I want the negatives to cancel in the middle, but it really doesn't matter. We get the same thing either way. I'm going to put this point first though. So we have -6 over 5 minus minus, then -2 over -3. So negatives, just make those pluses. So then -6 plus 2. Remember, adding makes it go up the line, right? The number line in the positive direction, so to the right. So negative 6 turns into negative 4. 5 plus 3 is 8. 4 and 8 have a 4 in common, right? So I can cancel a 4 out of both, meaning I have a 1 left and a 2 left. So that means I have negative 1/2. Well, are they the same? No, right? So they're not parallel. Are they the negative reciprocal? Yeah, right? So these are perpendicular lines because 2 is the negative reciprocal of negative 1/2. So that's how we can tell just from points whether or not lines are parallel or perpendicular. If they had nothing in common, so say this was a negative 1/3, well, 2 and negative 1/3 are not similar in any way, right? So that means that they would be a neither case, neither parallel nor perpendicular. So next thing with parallel and perpendicular is sometimes they would give us a line and then want us to write a certain type of other line, parallel or perpendicular line, through a certain point. So say we started off with the line of y equals 3/7 x minus 8, and we want to write a parallel line first. We'll do both, but we'll do parallel first, through the point 7, negative 2. So first, we should always identify the slope. They won't always give it to us in points, in slope-intercept form. So sometimes we might have to solve for y to see the slope, but this one's nice, it's right there. We don't have to do any solving. So our slope is 3/7. So parallel slope, we know, is the same, so we don't change it. That means we need to write a line with a point and a slope. Well, there's a specific formula for that, it's point slope formula, right? That's y minus y1 is equal to m times x minus x1. And then we plug in. So y minus the y value of negative 2 is equal to the slope, the parallel slope, 3/7 x minus the x value of 7. Now, this is in point slope formula. If they don't specify which format they want it, this is okay, right? But if they say they want a slope-intercept form, well then we just need to solve for y. So, simplify this. Minus minus is really plus, so that's y plus 2 is equal to, distribute the 3/7, so that means times x and times negative 7. So 3/7 x, can't change that one, minus 3/7 times 7. Well, that 7 is really 7/1. So those 7's can cancel to leave us with just 3. Then we need to do something about this 2. So we add it over to the other, it's already added, so we subtract it to the other side. So that means we have y is equal to 3/7 x minus 3 minus 2 is minus 5. This is a parallel line going through this point. Now this b value, you can't just arbitrarily pick, right? It's dependent on the point that's given to us. Okay, the slope is from the line, but the point tells us what b is going to be. And you just have to solve it out using this method. Now, if we wanted to write a perpendicular line through the same point, perpendicular to this line, so our perpendicular slope will be the negative reciprocal again. So that means it was 3/7, so we flip it, change the sign to be negative 7/3. Our point is still 7, negative 2. Guess what? We're going to use the point slope formula again. It's the same thing. we just changed the slope to be perpendicular instead of parallel. So we get y minus -2 is equal to -7/3 x minus 7. Now this one's not going to be as nice solving it out to slope-intercept form because the 7's aren't going to cancel, but we can still do it. So we get y plus 2 is equal to -7/3 x. Negative and negative make positive. So then we get 7/3 times 7/1. So multiply the numerators and multiply the denominators. So 7 times 7 is 49. 3 times 1 is 3. So then we need to subtract the 2. So we have y is equal to -7/3 x plus 49/3. But minus 2 we can't combine because it doesn't have the same denominator. So it was over 1. We want it to be over 3. So that means it's going to be a negative over thirds. So 2 times 3 is 6/3. Okay? So then we combine to make it y is equal to -7/3 x plus 49 minus 6 is 43. So 43/3. And 43 is not divisible by 3, neither is 7. So that's it, that's our line. This is the perpendicular line, that's the parallel line. They have opposite slopes, right? And completely different b values. So they're very dependent on this point and what their slope is. So that's parallel and perpendicular lines.